Specially named graphs. One branch of mathematics is graph theory, and graph theorists have developed specific names for certain kinds of graphs. One of those kinds is a regular graph. A graph G is regular if every vertex of G has the same degree and is R regular if this degree is R. We have a picture of 4 graphs, each with 6 vertices. The one on the far left is 0 regular because every vertex has degree 0. The second from the left is 1 regular because every vertex has degree 1. The third graph is 2 regular, and the last graph is 3 regular. A graph is regular if every vertex of the graph has the same degree. A graph is complete if every 2 distinct vertices are adjacent. And we call those graphs complete, and we have special graph names for them. The complete graph on 2 vertices is the first graph that you see highlighted. You can only put one edge between 2 vertices. The subscript number tells you how many vertices. The complete graph on 3 vertices is next and highlighted, followed by the complete graph on 4 vertices, and then 5 vertices, 6 vertices, and K sub 7 is a complete graph on 7 vertices. Every 2 distinct vertices are adjacent because they have an edge containing them. You might ask why the letter K was chosen for complete. Why wouldn't you choose C? Well, that's because C was already chosen for the graphs that we call cycles. A graph G of order n is a path if the vertices of G can be labeled so that V of G equals V sub 1, V sub 2, and so on to V sub n, and the edges of G are equal to the set V sub I plus 1. Those would be adjacent vertices, such that I is between and including 1 up to n. That's a path. To get a cycle, we first have to have a path. A graph G of order n greater than or equal to 3 is a cycle if the vertices of G can be labeled V of G equals V sub 1, V sub 2, and so on up to V sub n, and E of G has the same property as a path, V sub I plus 1 as an edge where I is between and including 1 up to n, and also union to that set is V sub 1, V sub n. Now let me translate that. You see the pictures. If we take C sub 3, the cycle with 3 vertices, and label our vertices V sub 1, V sub 2, V sub 3. So start at V sub 1. The first edge is V sub 1, V sub 2. The next edge is V sub 2, V sub 3. And then we're at the last new vertex, and there's an edge, V sub 3, back to V sub 1. So cycles look like this.